Hello, everyone. Thank you very much for coming. This is the session on Frugal AI and quantum-ready systems, driving growth, impact, and the SDGs. So, it is a privilege to be here at the India AI Impact Summit. I would like to thank the Government of India and the summit organizers for convening this extraordinary gathering by bringing together institutions from across more than 100 countries, spanning governments, multilateral organizations, academia, foundations, and industry. So the proposed flow for this session is going to be, there's going to be about 10 minutes of opening remarks, welcoming and framing the session. Then we'll have a keynote speech by Mr. Samir Chauhan, the director of the United Nations International Computing Center. Then we'll have a 30-minute panel session, and we'll have a few minutes for closing. So coming to my welcome remarks and my framing. So the scale of participation, as we have seen yesterday and today, and over the course of the next 3 days, what we are seeing reflects something important, right? Artificial intelligence is no longer something that is niche. It is now part of our everyday fabric. It is now a global public policy conversation. And the real risk today is not that governments will miss AI. The real risk is that they will deploy it badly, right? No, it's not because of lack of ambition, but because of fragmented decision making. So governments today are not struggling with enthusiasm regarding AI. They are struggling with the architecture of how AI is deployed. They are not worried whether to use AI, but what to deploy and at what cost. So this is the institutional capacity concept that we are talking about. And with that comes long-term consequences. So this is where this particular session sits. Much of the global AI discourse is dominated by scale, right? Larger models, more compute, more capital, but public institutions operate within a different set of realities. Budgets are finite. Energy is finite. Institutional capacity is finite, and most of the time it is uneven. Digital infrastructure especially, the maturity varies dramatically across various regions. It could be, India could be one way, in Africa it could be another way, and so on. But expectations from citizens, they continue to rise. So the question becomes, how do we design AI systems that are not just powerful, but deployable, and not just innovative, but they are institution ready, and they should not just be impressive, right? They should also be, how can you sustain this long term? So this is where the idea of Frugal AI comes in. So I have been talking about Frugal AI for the past 3-4 years, primarily because, especially when the ChatGPT moment came in, I realized one of those things that, yes, AI is there, but what does AI need? It needs a whole ton of physical infrastructure. It needs chips for training, chips for inference, data centers, it needs electricity, it needs water, it needs power grids. And do we have the capacity to do all of that? Maybe, maybe not, right? So Frugal AI is not about building smaller AI. It is not about doing things cheaply. It is about building deployable AI. It is about designing systems that work under real-world constraints of cost, energy, governance, and institutional capacity. It is about moving from AI ambition to AI decision architecture. So around the world, we see hundreds of AI pilots. Many might have also, the gathering here, many might have also read about the lack of these AI pilots scaling, right? So what is the issue? Many demonstrate technical feasibility. Very few survive procurement cycles, budget reviews, leadership changes, or integration challenges. If governments treat AI as experimentation, all they get is pilots. If they treat AI as infrastructure, they must measure it like infrastructure, like the total cost of ownership, return on investment, alignment with the Sustainable Development Goals. So this is what we are interested in, and the work together with the United Nations International Computing Council has been about, which we had a report out last December. So this past year, this conversation has evolved through institutional work. And together with UN, this is what we did, the report that I was talking about. This is not only a government conversation. Innovation often originates in the private sector and its research labs. But transformation of this happens when institutions adopt, scale, and sustain systems very responsibly. So responsible AI, trustworthy AI, how to do low cost, low compute, but in a way that is population scale. So these are the things we are interested in, all along the whole AI value chain, all the way from hardware, software, from the supply side to the demand side. So the most important thing is, will AI become transformative simply because it is powerful? Maybe, maybe not, but it will become transformative when it is embedded into public systems in a way that is affordable, resilient, interoperable, and citizen-serving. And the citizen dimension is very fundamental. AI systems must serve people, right? That's what we have, people, planet, progress. And the citizen dimension is fundamental. They must serve people, not just dashboards, not just ministries, not just investment metrics. They must reduce friction in services. They must improve access, increase transparency. Otherwise, scale becomes just noise. This is what we believe. So why bring also quantum readiness into this discussion? So you think Frugal AI is something that is different from all these kind of high scale kind of things, and quantum seems like a frontier technology and so on. So why bring quantum into it? AI is the current value chain, but quantum is the future value chain. Because technological cycles are accelerating, AI is reshaping digital infrastructure today, and quantum technologies may reshape computational infrastructure tomorrow. So quantum readiness is not about replacing AI next year. It's about strategic operationality, and it is about ensuring that the systems we build today do not become technological dead ends. It is about the standards that we need to have. It is about the talent pipelines, interoperability, institutional preparedness, and future-proofing public infrastructure in this rapidly shifting computational landscape. So the summit's framing, there is people, AI must be inclusive, affordable, and institution-ready. The planet, efficiency matters, life cycle, energy use, infrastructure footprint, sustainability by design, we need to take it into consideration. And progress, growth must be resilient, it should be future-proofed, technologically, economically, and strategically. Frugal AI and quantum-ready systems are not separate conversations. They are part of the same systems logic. We should build efficiently, we should build responsibly, and we should build with the future in mind. So today's session brings together precisely these perspectives: a multilateral systems lens from the United Nations, a state-level quantum infrastructure strategy, Amravati Quantum Valley from Andhra Pradesh, a population-scale AI deployment perspective reaching millions of citizens from Step Foundation. So if we get this right, AI investments today can become long-term strategic assets. If we get it wrong, we risk fragmentation, stranded infrastructure, and widening divides. So I believe this is not a technical debate. It is a systems decision-making debate. And to move from concept to institutional reality, we need practical experience. We need to understand how multilateral systems are navigating these trade-offs in real time. So it is therefore my pleasure to invite Mr. Samir Chauhan from the United Nations International Computing Center to share a multilateral perspective on how we move from AI experimentation to AI infrastructure, how cost, resilience, and SDG alignment must shape the journey. Thank you. Samir, please.
Thank you, Suresh, and hello, everybody. Pleasure to be here, and I echo your, thank you. I echo your note that I have to thank the government of India and all the organizers. And just seeing all of you here, the scale of what we can do with AI becomes apparent, and the impact we can make becomes apparent. So it's my pleasure to kick off this panel here today. Where do I start? So let me start by telling you a little bit about what UNICC is. So we are a part of the UN system, and we are today the largest strategic partner across the entire UN system for common trusted cybersecurity and digital foundations that are used by the entire UN system and beyond. The UN system is designed to support the world. They work with a very large consortium of other like-minded non-profit organizations. We work with them as well. So UNICC supports all of the UN system and large multilateral organizations like the development banks, the World Bank, Asian Development Bank, African Development Bank as examples. by helping deploy solution at scale. And I think the thought leadership and the work that's being done in Cambridge that Suresh spoke about is very relevant to what we do, because we are trying to deploy solutions around the world in very different contexts, and making sure they are fit for purpose and efficient are almost the baseline under which we have to build any tech that we roll out. We've been doing this for 55 years now. UNICC has been around for a while. But for us, this whole approach of frugal AI, we don't see this as a constraint. We don't see this as a limiting factor. We see this as a strategic approach we need to take. Suresh spoke about it. We see the same case in the UN. Hundreds of pilots, very few scale up into production. And of the ones that go into production, how many are sustained in the long term? The numbers drop off very, very quickly because there's a massive cost involved. Not just cost in building it, not just in training the models and the tokens you use, but also sustaining the AI over time. So that's why this end-to-end total cost of ownership approach that Cambridge came up with is very meaningful to us. So we believe this approach of frugal AI should become part of the digital foundations that governments and the multilateral system should use in how they deploy AI. So today, I think the global conversation about AI and the hype and the buzz is all about more and more and more. We need bigger models, we need more GPUs, we need bigger data centers, we need to generate more and more energy. Now it's like we need nuclear power stations everywhere, we need more fusion technologies are being discussed, nuclear power stations. So it's this race for more and more and more and more and more. And I think we're missing the point. I think the main mantra of the AI Summit is AI for people, right? AI for all, AI for humanity. And that's the lens through which we look at it in the UN, is how do you deploy AI so it's actually fit for purpose for everybody? So we are not looking at more and more and more complexity. It's about how do you make it affordable? How do you make sure it's accountable? So if you're deploying it in a particular geography for a certain constituency, to make sure that they actually say this is useful to me, right? I'm based in Geneva, and if I and my team work on a project, it may make sense sitting in Geneva, but if you're deploying it in a particular country, does it make sense there? Do they see value? That's the lens through which we have to look at this, right? Reliability. Is this something that can be sustained in the long term? All of these elements have to be more important than just sheer volume and sheer numbers of money and GPUs and power being thrown at this, right? So it's not brute force. It has to be much more elegantly thought through and designed and fit for purpose. It has to be secure. That's another key aspect. Everything we do in the UN and at UNICC, security is a very big component of that, because we have to make sure it's your data and that data is safe. And similarly, the models, you have to be able to tell, where does this data come from? Is this something people have voluntarily shared to empower this AI? So all of those aspects have to be kept in mind. Contextual design, as I said, understanding the context in which we're operating. Is it a situation where you have low bandwidth or you have low computational capabilities? So you have to deploy solutions that will work in those situations in the field. And then continuity. To me, that's the biggest element here, is this has to be sustainable. It should not be a flash in the pan where you roll out amazing solutions and 1 year later people don't see value in it and you shut it down. Big pomp and glory at the beginning when you launch, and then quietly it gets shut down. That is not success. So it has to be something that can be sustained and grown and scaled. So as a shared service provider, everything we build, we look at it from a scalability perspective. Is it fit for purpose in one context, but can it be deployed in other contexts, in other parts of the world, in other scenarios? So if we build something for agriculture, can it be used in health? If it's used for health, can it be used for children? If it's used for children, can it be used for outer space? Can it be used for nuclear energy, right? So there are very many different domains across the UN. And what we're trying to do is look at things so that it can actually be scaled up. And that's where I think the frugal aspect becomes very critical. Because if you're building something that's not designed intentionally to be frugal, when you try and scale it up times 10, times 100, the cost should not go up linearly with that. Because that's when you run into real walls, real roadblocks. what might make sense, I've seen projects where you deploy it in a particular state or a particular district. It looks great. Now try and scale it up to a national level, and if the cost goes up linearly with the population, that solution will not work, AI or otherwise, right? So that's why that frugal mindset to say right at the beginning, if you fine-tune it and design it, that scaling should not be a linear function from a cost perspective. So those elements have to be kept in mind. And then being in the UN, we also have to say there is an sustainability aspect to this. We all know that just by throwing brute force and more money, more and more energy at this, it's not sustainable. It is bad for the environment, bad for the planet, right? So there's a huge sustainability aspect to this that we need to keep in mind. So that's why I think the point Sirish made, looking at total cost of ownership, return on investment, and tying it to SDGs is very, very important, because SDGs are looking at the planet holistically. Is it helping life on Earth? Is it helping make it more judicious, more fair for everybody? All those aspects have to be thought through. And the one thing we've learned, and it's the real challenge today, is trust in governments, trust in the multilateral system. It's a challenge for us in the UN, I can tell you, to retain that trust. So when it comes to tech, we want to make sure any tech we deploy also builds that trust or retains that trust. It cannot be something that we're deploying today and maybe it solves some immediate problems, but in the longer run, people say, wait, but what the UN deployed is actually not beneficial to me as an individual, to my community, to my country, to my region. So that element of trust has to be baked in. Again, security, trust, all of those elements. So as I'm mapping out these points, you can start to see it's a very complex landscape, and I'm not talking as a technologist. It's all those different elements you have to keep in mind. It's challenging. So we have to think this through, design it correctly, and also make it work in parts of the world where they don't have the scale. There are some studies that show that only 5% of the compute capabilities is in Africa. So how do you deploy something that will work in those regions, right? We in India are lucky. Look at all of you. I see lots of young faces here. There's a deep talent pool. Sometimes countries don't have that deep talent pool. So how do you deploy AI in a way that you don't need to have massive horsepower of brain trust sitting there and trying to maintain this? All of those elements have to be thought through. So what we really need is that mind shift change. And I think the paper that Sirish spoke about that we collaborated with Cambridge, University of Cambridge on, is a starting point to start that discussion of saying, you need to think about this holistically, not just from a pure technologist's point of view, not just from a solutions design point of view, but a holistic end-to-end point of view of what does it take, what's the impact it can have on the planet. So this TCO to ROI to SDG, thank you, Sirish, that was a brilliant, I think, formulation. That's the mantra in which we are looking at AI. And any AI that we build is think about the total cost of ownership. That's the very first thing, and it's not just about building it, but sustaining it. And then what is the impact? And that return on investment is not in dollars or rupees, it is on the impact and the benefits it's having in society. And then how does it enable the SDGs? So end-to-end impact on the planet. All of those elements need to be thought through. So I look forward to this conversation today. I think we have, Sirish said, a great panel here. You can hear different perspectives from them. But please, what we're focusing today is not on cutting edge, latest models. It is about trust. It is about sustainability. It is about scale, reusability. It's with those lenses in mind that we're looking at AI. So I hope it's a fruitful conversation, and I hope you can learn something valuable today. Thank you so much.
Thank you very much, Samir. So now we will move on to the panel discussion. One of the things, so we have our panel members. We have Aditya Chabra from Step Foundation, Mr. Srivi Sridhar from Amravati Quantum Mission, Anusha Dandapani, again from UNICC. She heads the AI hub at the UN. So I'll start with Aditya. I'll start with you. So you're with Step Foundation. You have deployed agentic AI systems like Bharat Vistar and Amul Vistar directly to farmers. What does it take to make AI usable, trusted, and operational at scale in rural and multilingual contexts?
Thanks. Is this audible? Yeah, right. So you missed Mahavistar actually, which is the biggest of all, which has reached 2.5 million farmers now, right? So I think early on when we started as well, we thought of it as a distant dream. You know, a few hundred agriculture extension officers using it here and there. Will it ever scale, right? Then we continuously started to tweak the system. The whole team, bureaucrats, I'll tell you, they were involved in the middle of the night on phone calls with the entire AI team. They had a much better understanding of AI than most people would, I would say, towards the end of it. By tweaking the system, every little thing, they were accounting for every little thing that the farmer may ask. How should it respond? What data does he need? What data does he not have? Over time, within a span of 6 months, we saw massive coverage, massive amounts of farmers, just word of mouth, you know, flowing through all of farmers, and we saw huge numbers. So now we have 2.5 million farmers. Then I think the challenge came as to, you know, the same cost of compute. What is the real cost of compute here? How much are we essentially? How much are we paying for each question? How much are we paying for each conversation? And the real flip to that was when, you know, at Step we were all discussing about what is the actual value of it. So if you could also think of, you know, what is the value of actually going to a farmer without AI, let's say, and giving him the advice that he needs, giving him, you know, the information about a scheme. Some person, some extension officer who's already very overworked will have to, you know, travel miles and find that farmer, and that farmer has to communicate it right and be able to offer that advice. So also when we think about cost, I think the point to think about is what is the value that is actually bringing as well. Yeah.
Thank you very much. Anusha, I want to ask you next. So you have been at the UNICC for a while, but you had worked at financial institution Barclays before. So you have a very diverse background from the perspective. How should governments evaluate AI systems and multilateral organizations as well? How should they evaluate AI investments beyond immediate efficiency gains, especially when long-term societal impact and institutional resilience are at stake? Do you have any comments?
Yeah, I think this is exactly the tension that we do observe between many governments and the multilateral institutions that we are collaborating and working with, that they're also navigating today. Yeah, I would frame the response to your question in 3 practical shifts that we do see, that we are seeing right now. The first shift that we see is actually moving from speed versus trust. As Samir alluded to, trust is not a brake on innovation. What we see is that if we are able to adopt and accelerate by making sure that we have governance, risk assessment, and also accountability baked in the design, not having it as an afterthought. That is one of the very prime focus priorities of ours. And the second that we do see is like a staged and a risk-based approach. You know, the approach wherein we bring in an AI sandbox kind of an infrastructure where there is low risk of you testing and making sure that operationally you're able to adapt to AI, and making sure that like this allows innovation to move quickly. This is you for going through the procurement activities and making sure the assurance is in place and the safety and the guardrails that you need to have in place for an enterprise ecosystem. We want to make sure that the focus of having these things with the societal impact being high as our prime focus. And the third that we do see is the practical mechanisms of having embedding human in the loop and having clear model documentation, and what we do, which we are collaborating with most of the institutions and academic institutions, is this red teaming and independent testing of these AI models. Thereby it gives not only the purposeful but also right-sized AI models that we can bring to the fruition. So it is not just about ultimately the goal of not having the technological success, but making sure that there is public value that we are bringing to our stakeholders, and making sure that we maintain the rights and the dignity of the human, and the human-centric design of AI is what we are focused on. Yeah.
Thank you very much. So, Sridhar, I have been working with you for a while now on our Frugal AI lab in Amravati. So, Sridhar comes with the background also again from private sector. He's with Tata Consultancy Services, but now he's deputized to the Andhra government as the mission director for Amravati Quantum Valley. So, how do you see a tension between quantum and AI? And how do you see governments need to look at that from investments perspective, from deployment perspective, and scale perspective?
Thank you, Suresh, and good afternoon all. Thank you for having me here. Great question, Suresh. So for those who are new to quantum computing, maybe I just give one-line introduction to quantum. So quantum significantly accelerates AI. So it provides either a quadratic speedup or exponential speedup to your AI algorithms, so which means this is another important processor that you're going to see apart from CPU, GPU. You will also have QPU, so which is a new processor that is going to come. But having said that, so this is also in the state of research, so there are many problems which are intractable today, which we cannot solve it irrespective of the amount of GPU that you add to the systems. So you need quantum computers. And it's also important to invest on this technology very early. And Government of India has taken a very nice initiative of National Quantum Mission, so which is a 6,000 crore mission that has kickstarted initiatives on building the technology around centered around quantum. So this is extremely important even from the AI perspective, because so just imagine all our AI algorithms are getting significantly accelerated. So some of you must be using AI model, vision models. So let's say you are using UNet, so you can significantly accelerate that model using quantum computer. So which means, so we have to carefully plan our investments. So instead of investing too much heavily on GPU, so there might be a solution where you can bring a quantum computer and then create a hybrid architecture, so which will solve the problem. Right? So from that perspective, we need to start investing into these technologies. And what Government of Andhra Pradesh has done is they've done a PPP model, public-private partnership investment on bringing TCS and IBM together in bringing India's first quantum machine into Amravati Quantum Valley. So this is the first state-of-the-art machine that is going to come. So India has a lot of scientists who are already working on these technologies, on quantum technologies. And what we are now aiming for is not just looking at the machine and consuming all the services that quantum can do. So we are now questioning, so can we make this machine within the country? So in order to, again, going to the theme of having these frugal systems, so we need to look at the holistic perspective. So buying the box and integrating into an existing infrastructure will not give us that kind of architecture. So we need to look at every part that goes into this machine, and can we question, so can we do this in India? And can we manufacture this box from the Quantum Valley? So that is what we are questioning right now, and we are trying to do that. And to do this, again, we also need skills of people. So, and this is where the capacity development initiatives are very important. And this is where we've taken some steps in training large section of people on quantum technologies. While good section of people are already learning AI, I think AI is not new to many people right now, but quantum is relatively new. So what we have done is we've taken training, we've trained large section of people. About, in the first phase, we trained about 50,000 people at 500 rupees. So you can imagine, so a foundation from US has come and trained 50,000 students in Andhra Pradesh. So we again went for the second phase. So throughout the country, about 2 lakh students have registered for this quantum training. This is free of cost now, right? And now we have about 100,000 students coming from Andhra Pradesh learning this technology. We are preparing the roadmap to have these skills which are required to build this next important technology and prepare for the future. And while this is happening, so there is also opportunity to build quantum machines. So with a goal of about, in 2 years, we should be manufacturing about 100 quantum computers from the state. So that's the objective with which we are working, Satish.
Thank you, Sridhar. So this is primarily a question for Aditya, but others can also chip in. So one thing that so we are in India. So majority of people speak multiple languages, right? And then let's say there are maybe 500 million people who call Hindi as their mother language, mother tongue. And then there are hundreds of millions of people who call other languages as their mother tongue: Telugu, Tamil, Kannada, Marathi, Bengali, and so on, right? From your point of view, from Step, what are you thinking about when you are thinking about like population scale solutions, citizen-centric solutions, what governments can do with respect to deploying, because large amounts of our population are also illiterate. So voice-based models, multi-model solutions. So maybe can you talk about it?
At Step, I think, see, when you say population scale, you still have to look at all the communities possible. One example of that in Maharashtra is we're looking at Bili. Bili is a tribal language written in Devanagari script. Very difficult, very limited data. I think I saw Karya team here as well. They were involved in it. A lot of the government departments were involved in this project. So they collected all of this data from the grounds up. They recognized that Bili, there is a substantial population, a few lakh people, which is not small, which is not a small number. And they essentially started this project early on. Early on in the advent of Mahavistar, they started collecting Bili data. And now we have models coming out of AI for Bharat that are actually translation models, speech-to-text model, text-to-speech models. So the whole stack, in the initial phases of it, we were thinking of how do we integrate other tribal languages, let's say. And Bili was an experiment that I would say right now it is at a stage where very soon Mahavistar will be able to offer tribal farmers also advice in Bili. So, that is the wholesome approach that we are taking generally when it comes to languages.
Yeah. Anusha, for you, so there is the AI hub at the UN. Then how does it work internationally with multiple governments? And also, how does Frugal AI fit into, you talked about AI sandboxes, so experimenting, piloting, and all these kind of things. How does Frugal AI, or the concept of using scalable AI solutions with low cost, low compute kind of thing, how does that come into the picture, and what do different governments feel about how to utilize your AI hub?
So perhaps I can talk about what we have prioritized as one of our strategic initiatives as part of our AI hub is investing in skills. Because reskilling and upskilling of not only our stakeholder community, but also the user community that we see as a very big gap in adapting to these technologies. Yeah. So what we have done, essentially, as Samir alluded to in capacity building, to bake in those skills and the institutional knowledge, and how do we want to govern these AI technologies apart from capacity building. Because when it comes to skilling and upskilling for an organization like ours or the institution like ours, we cannot be having this one-size-fits-all approach. So what we did is collaborated with academic institutions like yours, and also making sure having education partners who are not only giving us the opportunity to map the kind of the persona needs that we have in these organizations. So what we did is, instead of going with a tool-based approach, we thought this through with a curriculum that is context of the organization and the persona of the users who are actually going to use the AI within our ecosystem, to sort of get familiarized with the tools first. It's not a tool-based approach. It's more of a skilling approach where the capacity of the individuals has the human component to it, where the component of being the public sector users or our civil society who is going to upskill themselves, they need to understand based on a use case based approach, in the sense that it's not just about how do you use the tool, where can you contextually use this tool. So that the academic training and the collaboration that we have is to make sure the content that we are sharing with these institutions is fit for purpose, and the construct of the organization, and the scale that we are operating it with the governments and also the institutions that have this need. So we are tackling the citizens first, the AI citizens first approach. So that kind of gives us the possibility of not only investing in the skills or the institutional skills, but we are also embedding the tools that they can access via our AI sandbox. So it is like a kind of a learning by doing approach is what we are currently focused on.
Thank you. So I'm going to ask Sridhar a question, but I'll also ask the audience to think of few questions later on, so that we could get few questions in from the audience as well. Sridhar, one of the things, obviously, is we want to have in India. Hello. Yep. We want to have in India the supply chain of the quantum ecosystem. This is what you said. So we have, can you talk a bit about the value chain for quantum that needs to be in place? So the supply chain is one, but what about the value chain, and how can the citizens of the global south, be it India or be it from people from other parts of Asia, Africa, or Latin America, the global south broadly, what is it that can be used from Amravati as some sort of benchmark or anything like that?
Okay, so the supply chain part. In terms of supply chain, so we have multiple options of making quantum computers. So we have multiple technologies that we can use to arrive at building a quantum computer. So there is an opportunity for us to build cryogenics, new materials, new fabrication methodologies, etc. So which will all help us to build, and photonics as well, which will all help us to build new quantum computers. So which will help us to solve some of the most complex problems. So now let's take at the application infrastructure. So what we can solve. So we can solve some of these intractable problems in drug discovery. So today the drug discovery life cycle takes about 12 years, 10 to 12 years. So we can significantly reduce time by using quantum computers. So we use AI also there. AI augments plus quantum. So most of the pharma companies today use quantum as a baseline technology and exploring these drug discovery life cycles. Similarly, so the logistics optimization, the supply chain optimization problems are very good. So these are some things that you can optimize, and this is especially to the context that you mentioned about the technologies that are doing good for the global south. So you bring significant optimization capabilities into the supply chains by using quantum technologies, especially in logistics optimization. Similarly, you also have opportunities to improvise the risk management in financial portfolios, financial modeling, etc. So those again will help all the things. But the benefits of all these things will be felt by the people. And another interesting important point is the energy aspect. So with data centers, Samir was talking about setting up the nuclear reactors for powering these data centers, and quantum will provide that optimum. So with quantum computers, you don't need to use much of energy, but can still solve the largest of the largest problems. So with all these things, the benefits are going to come to the people, and this will help in the long run.
Thank you. So first, I'll gather some questions.
Hello, my name is Akanksha, and my question is to Sridhar CV. So we know that AI is moving at a scale and it's catching up, and there are a lot of infra-level, changes that will be needed to get done when we move at scale, and so will be needed when quantum comes up. We will even for now with PQC, we have the keys where we need to make modifications to the HSMs which are not compatible with the key sizes that we need for the new algorithms. So how are we making sure that our systems which are being built for AI today will be crypto agile and quantum agile as well?
Hold on to that. I'll take a few questions and then we'll get a rapid answers from all of you. There's only 6 minutes left.
Hello panel, my name is Karthik Bhadwaj, and my question from the whole panel is that how do you see the future of the quantum systems for pre-seed startups that are working on quantum machine learning and
As making a quantum computer is super hard, what is the practice being followed for your government? Are you tying up with US-based companies and co-designing with them, or are you building a quantum computer for ground up? Both are fine, but what is the approach? Thank you.
A lot of questions for Sridhar, but
All
maybe
right.
others can pick up as well. Final. Sorry.
Thank you so much. So we are talking a lot about frugal AI or AI from the point of view of startup AI producers or the service providers. How about the other side of the story? Startup AI users, those startups which are using different, they are into different sectors or sunrise industries. How are they seeing AI adoption? And if we go by the statistics or the data or the reports, the AI adoption rate is extremely low comparatively the talks that are going on all around the world. So what could be the factors, underlying factors from the point of view of startup users, why the adoption rate is still low, and how can we expedite it? Thank you.
So maybe that could be for you from Xtep or so. Please go ahead.
Maybe first you can start, and after that I'll address all the quantum questions.
So I have a different experience, at least from the point of view of end users, from what I've seen, and I can only speak about the farmers that I've seen, that they have really adopted it, and in fact not just with Vistar. Even before, we were surprised to know that they were familiar with ChatGPT. They were familiar with all of these tools, right? So I think there was some knowledge already existing. What I think they struggled with initially to understand is that a voice bot is actually a bot. It is not real, right? So we had to add a little introduction at the beginning. But from what we've seen, there is a significant understanding even in that part of the population. But it could be that we have not seen all of them, right?
Sure. Yeah. So let's take the first question on PQC. So yeah, the post-quantum cryptography is just gaining traction. So the standards are very new. There are no frameworks, or there are no frameworks for testing and evaluation per se as of now. But this presents a huge opportunity for all of us. If AI will take off few jobs, then post-quantum cryptography will give a good amount of jobs, because we need to do this migration at scale, and there are regulatory requirements in some countries. So India, we have the guidelines that are framed, but there are no regulatory requirements in India as such. So RBI at some point will put this in cybersecurity framework, and then that's when the Indian banks will start migrating, and that's when you'll see a lot of opportunity in the country. But again, taking that to AI, again, we will have to migrate even the AI systems onto the post-quantum cryptography as well. So that will make the systems more secure. So that's a huge opportunity in front of all of us. Now, coming to the quantum machine learning for startups. So here, the paradigm is a little new. So the conventional AI programming methodologies so yeah, whatever approach that you're taking will help. But if you're trying to write this for quantum, so you need to have a different skill and different methodology to run this on a quantum computer. And it is very expensive today. So to access these machines, it is significantly expensive. And if you hear the cost that will take to inference one image on a quantum computer, so this is super expensive as of now. But there are opportunities. So you can access this smaller number of qubit machines, and you can also run simulators on your own desktops and then try out some of these algorithms. Value we'll see once you reach about 1,000 qubits. So today, most of the quantum computers are in the range of about 100 to 200 kind of qubits. And once we reach 1,000 qubits, and that's when you'll see the value. And naturally, I need not tell, actually, that time you will only start using it. So that's what you'll do. And the third question is about the supply chain of this hardware, whether we are making it bottoms up or we are buying it from the US. So the IBM investment is like buying from the US. So it's a box that we will be accessing on the cloud. But whereas the programs that are going on in India as part of the National Quantum Mission, so all these are trying to make indigenous hardware, also every part indigenously. Right? So we have the quantum processor, the cryogenic systems, then the cables, microwave amplifiers, etc. for a superconducting system is all made from India. And we have a lot of common manufacturing facilities that are coming from different institutes across the country, like IIT Madras, IIT Bombay, IIT Bangalore, and IIT Delhi. So they're setting up a lot of common infrastructure facilities which will help us to manufacture these quantum machines. So we are trying to make this grounds up from the country.
Two more questions. Okay. One here. Maybe somebody from the back. Okay.
Hi panel, this is Ocean. The question is for Sridhar sir. In terms of quantum computers, currently is error correction a real problem? And are we trying to invest in it? And is there an opportunity for young individuals to work on something which will help reduce the cost or reduce the compute required for error correction right now?
We'll also gather a couple of questions and then just a moment, yeah.
So yeah, my question is very straightforward and simple. What would be your advice, Mr. Sridhar, regarding guiding the youth of current nation towards what can they, technical, non-technical, what should they start doing, learning to be upfront in that technology that you're building?
Last question, yeah.
Very quick question, which is, when we talk about responsible and ethical AI, or in this case, frugal AI and citizen-centered AI, would you advocate that the correct route would be public-private partnerships, / United Nations, multilateral bodies, rather than leave it to the cowboy tech, runaway, uncontrolled developments in AI? And this is for everyone's one line to share.
I agree with you, so I'll start with that, but others can take their own. This is me, on X and other places you said, these are my own personal opinions, maybe not associated with Cambridge. So, anybody wants to take?
Sridhar, you want to tackle it first and then we
Yeah,
take
so
the
the first,
responsible AI?
okay, fine. So the first question on error correction. So it's extremely important. Actually, if you go and see the Fujitsu center there, so they've displayed a model quantum computer there in one of their booths, right? So today's quantum computers are extremely noisy, and they are actually built in a architecture where a group of quantum processors are brought together and built, right? And this requires good amount of error correction, and these skills are extremely important. So that is one. The second part to this one is, as you increase the number of qubits, so because these quantum processors are not very stable, so you have to handle error correction. So the number of actual qubits versus the logical qubits, the ratio is very small. So though you may have bigger number of physical qubits, so you'll have very few usable logical qubits with which you can work upon. And the rest you need to handle with error correction so that you can make use of best of this technology. And your question is about whether we are working on it. Yes, so we have a very decent team working on this technology. And this is also the area that we need to focus upon as the quantum computers gain number of qubits. So this is one of the most important skills. Otherwise, even if somebody gives a very big quantum computer, so you'll not be able to handle it. So that's pretty much very important skill. Now on the question of the path for education. So again, quantum is no different. So it is an extension of the current AI, cybersecurity, and the conventional science skills like bio, etc. Right? So what we are only trying to do is improvising by adding significant computing capability. So which means, again, so as a quantum engineer, what you will do is, so you will benchmark your algorithm. For example, you are using time series forecasting, right? You write this in classical AI, so using one of the best state-of-the-art methods, and then convert that into quantum and also benchmark this and look for efficient result. So which means your classical skills will also get better. In fact, we have one case where customer came to us to convert the problem into quantum. But what he has seen is during the process he realized that his own classical methods have started giving better results by applying some of the quantum principles. So the point is, so these are not new skills, these are extension skills. So we are not displacing some technology and getting a new quantum skill into our portfolio. So we have to learn all the things together and slowly start shifting and learn using quantum computer. Thank you.
Anybody wants to take?
So on quantum, just quickly, so we are working on both QKD and PQC today in the UN on starting to re-encrypt data that is most sensitive. We are intentionally looking at solutions from all around the world, right? Because this is still defensive measures of encryption. But when it comes to actual quantum computing, you make a very good point that, one, we should understand what's available today, whether it's coming from IBM or from any other large company. But technology today is such a big geopolitical issue that I think every country that has the wherewithal, and I believe India does, we need to build from the bottom of the stack. So when you look at the investments that are happening in quantum around the world, India is also at par with some of the biggest, richest countries in the world in making massive quantum investments. And with the frugal mindset, that money could go much further in India. And it starts with education. So that's why I'm very pleased what Amravati Quantum Valley is doing and setting some very high targets to educate all of you. So step one, in my opinion, is you all need to go and understand there are basic quantum courses you can take online. We have one that we launched with the Dutch called Quantum Delta. That's available to everybody in the world for free. Start to understand what does it mean. There are certain problems where quantum will be very powerful, and others it's not so much. So understand what are those scenarios, what are the use cases. And just like with AI, start with what is the problem you're trying to solve? How will it help people? Who will be impacted by it? Start from that and work backwards. That would be my recommendation to you. But as a national strategy, I'm glad India is focusing on every element of the stack, starting from designing our own hardware, or saying, okay, let's source the best that is available today, but let's start building on top of that, building actual solutions, scenarios. There are known use cases like drug discovery, which you spoke about, in financial services, in energy optimization, supply chain optimization. So those are domains. If you become business experts in that, that's another angle. You don't have to be a quantum engineer. Become domain experts in that, and then you can apply those skills as and when quantum computing gets here. And to your question about AI, I think that's the biggest lesson from what's happening in AI, is that today, I'm personally, and again, I speak as an individual, not as the head of a UN agency, I'm very pleased that countries are in the game and when it comes to quantum. Because we have to make sure that technology is designed so it's fit for purpose for different parts of the world, and not pushed from one particular direction onto everybody else to say, this is the latest cutting edge thing, you have to buy it, otherwise you lose. And oh, by the way, this is how much you have to pay us for it, right? And forget the guardrails and forget whether it actually has errors or flaws or biases. So I think that's a big lesson learned. So in a roundabout way, what I'm saying is even for AI today, it's the beginning of a long marathon. So there are no winners. There might be people who look like they're winners, but it's the first round of a long marathon. So we need to invest more heavily. We need to build open source AI. We in the UN are looking more and more at open AI, open source AI from around the world. So that's the trajectory we should take as humanity, in my opinion. Thank you.
Thank you very much. So we just got a few minutes left to wrap up, so I'm going to do some concluding remarks. So thank you very much, Samir, Sridhar, Anusha, and Aditya. Very honored to have you on the panel and in the session. Thank you all. Pleasure and honor to have you all here. So one thing I'll tell you is I don't come from an AI background. I come from an innovation strategy background. So we should not leave technology to the technologists. Yes, we need them, but we need everyday people who use these technologies to have a say in how this technology is being deployed. And that's how I got involved, is how and why is these kind of large language models being deployed. So if they are coming from, abundance, a land of abundance, the innovation is one way. But in where we don't have abundance of these physical infrastructure resources and financial resources, how do you go about and do that? So that's the space I have been in. Frugal innovation was the space I have been in. And for me, frugal AI was very natural to do because we don't have the infrastructure that US has or China has in India, but we do have talent. We do have ingenious ways of making things happen. So I believe frugal AI is the way for India and especially for the Global South. And with that, I'll conclude the session, but I'll ask for a moment that we want to take a selfie with you. So please, just a moment. Come on, let's take a selfie. Thank you. Thank you very much.
Hello. Requesting Requesting everyone to exit from the left-hand side door, please. Or the right-hand side door for you. Yes.
Hi, I request everyone to please clear the hall. This is a closed event. You cannot enter for the next round if you don't have a badge. There is no entry from this side. I'm requesting everyone who has pushed their way in here, please turn around and go back. There is no space. You will create a problem. Please move back and step out. Those seating, please leave your seats. I request everyone to